Day 5, 5, 4, 3, 2, 1, and we're going. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between the stacks. This is going to be a Tower of Hanoi problem, isn't it? To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, your puzzle input. For example, okay, D, N, C, Z, okay. Move 1 from 2 to 1. So I guess D to, okay. For this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Z is on the bottom, M is on the top. Stack 2 contains 3 crates. From bottom to top, they are M, C, D. And finally, stack 3 contains a single crate P. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above arrangement procedure, 1 crate is moved from stack 2 to stack 1, resulting in this configuration. In the second step, 3 crates are moved from stack 1 to stack 3. Crates are moved one at a time. So the first crate will be moved, D, ends up below the second and third crates. Then both crates are moved from stack 2 to stack 1 again. Because crates are moved one at a time, it will be C on the bottom and below M. And then finally, 1 crate is moved from stack 1 to stack 2. Okay. The elves just need to know which crate will end up on the top of each stack. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3, so you should combine these together and give the elves the new message CMZ. After the rearrangement procedure is complete, what crate ends up on the top of each stack? Okay, so is it always going to be 3, right? It's not necessarily always going to be 3. Well, let's see what the inputs are. So let's grab our input. Put it in there, and then let's grab our test input. So more than 3. Okay. Okay, so okay, our return value is going to be C and Z, and then so we're actually going to want these to return strings today, not longs. I don't know why I'm updating that one. And then the first part we need to do is figure out a way to get the data from this graph here into a something we can use. So we also need to split this because really this part needs to be actioned on and this part needs to be actioned on separately. So something that I did after the first day is I added a new utility here, space delimited, which is just basically going to split on new lines, and it's going to give us a list with in this case 2 items. So every time there's a space, it adds a new item to the list. And each element in that list is going to be a list of the strings of the lines. So basically, because like the first day we had groups, and so like we're saying like this first group, the second group, this third group. And so basically this chunks down to groups that we can action on. So that's going to be space delimited, and then I guess we'll need to import that. And then, so that should give us a list of string. And then basically what we want to do is that first list we want a set of stacks. How many do we have? 9. Okay, so this is going to be this is going to be ugly. Don't do it this way. I will figure out a better way to do it and put it in the GitHub below. Basically, we want to do a list of stack type in Java, stack of car. So it's going to make us import that, I'm sure. Oh, I need to update my IntelliJ settings. And then we're going to want 9 stacks. So for I in 0 until 9, again, this is just a little Kotlin range thing that just does this for loop 9 times. Stacks.add stack, I guess, right? Yeah, okay. Cool. And then from there, what we want to do is for line in the first part of the input. So again, this is going to be everything above the break. So this whole section. We're going to want to break it out. And the other thing is, so these are always 1, 2, 3, 4, 1, 2, 3. Okay, there's no extra fourth one, but they're always 4 before the next one. So what we can do is we can use our chunks, which basically it's a Kotlin function for collections. It's going to give you, if I say like chunk 3, it's going to give me the 3 items, and then 3 items, and then 3 items, and it's going to come back as a list. So what we want to do is line.chunk 4. And then the last one will always just give us the remainder, even if it's not quite 4, so that's fine. We don't care about adding an extra space in there. And then from that, we're going to map that. And so again, that gives us a string and up to 4 characters. And then we only care about this character. Oops, I did not mean to put that in the second window. We only care about this character here in the first index. So we're going to say it dot substring of 1 to 1, or no, 1 to 2, because it'll be the index after. And then we need to say to car. I can't give it to car, I guess, because it's still going to be a list of strings. So we would want to say, actually, I guess we can just say first element of that substring. Cool. And then, so that's going to give us basically a list of cars. Some number of those cars are going to be spaces, which we'll need to remember to remove in a minute. And then for, I guess we don't need to do anything else there. So we want to do 4, so 4 container and containers. We'll just shorten that to C. Val item is going to be just C. And then if item is not a space, so we can just say if item is in A through Z, they are capitals, right? Yeah, all capitals, great. So item A through Z, this is going to make us a range that includes A and Z and everything in between as characters. And then, so if our character is a letter, and so this is going to ignore spaces, we'll do stacks. How do we get which stack we're in? Okay, we're going to need to change this to an index. There's probably a cleaner way to do this, but containers I then, and then so stack I is going to, we just push the item. Okay. And then, So that should go through and give us all of our characters. This is going to filter out the ones that we don't care about. This is going to push them. Now it's going to push them from the top down, so they're going to be in the wrong order. So for stack in stacks, we just want to do stack.reverse, I think, will work. Which should basically just reverse the stack for us. So put it back in the right order. I think that's it for this. This should just build us our stuff. And we can double check that real quick. I'm gonna put in a breakpoint here. And then I need to update that to a string, I guess. Okay, so we have 3 stacks, great. And the first stack, we've got N on the bottom, Z on the top, which is wrong order. Oh, okay, yeah, that's my mistake. This should not happen every time we add a line or go through a line. This needs to happen after we do all the lines. Okay, that's just brain fart on my end. Okay, and then Z on the bottom and on the top, because these are going to be in reverse order, and then M, C, D, so that's correct. Okay, and then the next thing we need to do is do the second part of the input. So for line in input 1, and then this is going to come in as this, right? And so we don't actually we don't care about that, right? I don't think that changes. So we only care about this index, and this index, and they're always going to be single digits in this case. So this is probably not the way you should do it, but whatever. Well, okay, it actually wouldn't matter in this case. So we're going to do val nums equals line.split on spaces, and then val amount is equal to nums 2, or no, nums 1, and then val from is equal to nums 3, and then val 2, I can't do 2, it's going to be target equals nums 5. And then for, we're going to have to do it X number of times. So for I in 0 until amount, we're going to do the item, we need to just pop off, or I guess what we can do is, all right, stacks target, we're going to push on stacks from dot top. Is this going to complain about what now? Oh, yeah, those are all ends. Okay. And then I think that should be it for that. And then we can throw a breakpoint in here and see if our stacks look correct. What are we breaking on? Exception in thread on stack pop. Oh, yeah, so, okay, yeah. So this one is bin 1, but it's actually going to be index 0. So we need to subtract 1 from each of these. So 1 will become 0, 9 will become 8, etc. Okay, let's try that again. Okay, so stacks, and then should be a C, which is correct, an M, and then a P, D, and Z, which is correct. So the last part that we need to do is figure out how to concatenate these, which is just going to be stacks.map. If it's not an empty stack, because if it is an empty stack and there's nothing there, we don't want to concatenate it, or we don't want to pop, because that will break it. Is not empty, then we just want to do it.pop, else we don't want to do anything. And then we need to create a string. Is there concatenate? No. Okay, I think it is join. Join to string. Okay, and then we can go check failed. Oh, okay. I think on our join to string, we need to put a separator in, otherwise it's going to do comma spaces by default. Awesome. So there is our first answer. Move down here, we'll plop it in, and that's the right answer. Okay, we're 1 gold star closer. Continue to part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a Crate Mover 9000, it's a Crate Mover 9001. Oh no. The Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin the same configuration. Moving a single crate from stack 2 to stack 1 behaves the same as before. However, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order, resulting in a new configuration. Easy enough. Next is both crates move, okay, blah, blah, blah. Okay. In this example, the Crate Mover 9001 has put the crates in a totally different order, MCD. Before the rearrangement process finishes, update your simulation so that LELs know where they should stand by to be ready to unload the final supplies. After the rearrangement procedure completes, what crate ends up on top of each stack? Okay, so our second answer, I think it's going to be basically exactly the same thing. I'll probably refactor some of this stuff and move the code out, make it cleaner or whatever. Again, get a hub repository. But basically we're going to do the exact same thing, but instead of pushing directly onto this stack, what we want to do is we want a temp stack, and then we're going to push the temp stack, and then for we can just do while is not empty. Is not empty. Stacks target dot push temp dot pop. It's a little hacky, a little bit cheating. We're just gonna flip it onto one stack and then turn around and flip it over again. So it just reverses the order again. I'm sure there's a cleaner way to do this. I think there's like a take option maybe, but I don't care at the moment. I will clean it up at the end. Oh, I need to update our, we are looking for MCD. All right, and then that should be our second one. We can throw it in and submit, and hey, that's right. You completed day 5. Cool. And then I will see you guys tomorrow. Probably late. I've got a hockey game, so probably won't get home till well after 1 o'clock Eastern. So if you're waiting for it, don't. Bye, guys.